Welcome back, you lovely people. This is the answers to the work that you've been doing today, the number sequences, the fraction number sequences, which is quite challenging, I feel. I think this is pretty tricky today, but let's see how you've got on anyway, or how you're getting on. Like I say, if you are watching this and you haven't finished yet, it might be a good idea to have a little look at the answers, because then you might be able to understand exactly what goes on. Okay, sorry. So, first of all, we've got number sequences. Sorry, my camera's in a different angle today. I've had to put it down there because it kept falling off the top of my computer screen. So it's a bit weird. It is a bit weird, but still. Oh, it's night time. I need some tea. I've not had my tea yet. I need to have something to eat. Right, so the first one says complete the number line. So we start off with 1, 1 and 1/5, 1 and 2/5. And we need to put in the answer there. So the answer, of course, if we look at the sequence, it's 1, 1 and 5th, 1/5, 1 and 2/5. And if you're not sure, you've got this visual down here. Okay, but it's pretty. I think it's pretty straightforward. You can see what the pattern is. So 1 and 2/5, 1 and 3/5, 1 and 4/5, and of course this time it's not there. So you need to draw in one block with 5 sections all coloured in. And then underneath you need to do another block with 5 sections, but only 4 of them coming in. That shows 1 whole and 4/5. And then lastly, you've got 2 whole. 2. Yeah, so 1, 1 and 1/5, 1 and 2/5, 1 and 3/5, 1 and 4/5, and a 2/5. I wish I'm making these say fifths. Right, going from underneath, we've got B. And we start again with 1. But this time the jumps are different. Okay, the sequence is different because we go from 1 to 1 and 2/5. Okay, so that means we're jumping 2/5 each time. So 1, 1 and 2/5. So we need to think about, okay, we're jumping 2/5 each time. 2/5 add 2/5 equals, remember when we're adding fractions together, we don't add the denominator, that stays the same, but we add the numerator. So basically it's 2 adds 2. So that'll be 1 and 4/5. And then underneath, you need again to draw some boxes. So 5 blocks, shade those all in, and then underneath another 5 blocks, but this time you're only going to shade 4/5. Okay, now we think, okay, we've got 1 and 4/5. You now need to add another 2/5, and if you wanted to, you could draw it under there. So you can say, right, okay, I need to add another 2/5 to that. So to do that, I can shade that one in. So copy that, shade that one in. Then right, I need another block of 5 underneath. So I'm going to draw another 5 there and shade one in because we're only adding 2/5. And then we can see where that leaves us with 2 wholes and 1/5. Jump up to the next one, and this is quite nice because it's got the visual underneath. Okay, so you've got 2 and 3/5. And then lastly, if we're adding 2/5 each time, we're left with a whole number, which is 3. Alright, so each time we're adding 2/5. And if you're not sure, I've got these visuals down here to really help you. Right. Now underneath we've got this complete the number line. Okay, so we've got 4/7, 5/7, 6/7, so that shows you above anyway. So down below is going to be the mixed number, and up above is going to be the improper fraction. So you might want to start doing the number above, the improper fraction first of all. So 4/7, 5/7, 6/7, 7/7. We know that the denominator is going to stay the same, but the numerator is changing each time. So it's going to be 8/7 and then 9/7. So down here, we know that is going to be the same. Okay, because that is still a normal fraction, it's not an improper fraction. Okay, so we have 4/7, 5/7, 6/7, 7/7, of course, is 1, and then we've got this 8/7 here, which is 1 and 1/7, because we say, right, how many 7s in 8? 1. How many left over? 1. That remainder we turn into a fraction, and we we're working with 7, so it has to be there. And then this one on the end, if we've done the sequence corrected on the top, we can say, okay, how many 7s are in 9? 1. That's our whole number, 1 complete whole. And then how many are left? So from 7 to 9 it's 2. So we know that remainder 2 we're going to change into a fraction. And that fraction is 2 sevenths. So it's 1 and 2 sevenths. Same again up here. This time it's a little bit different because the jumps, the sequence is different. So again I would start with these fractions at the top. So we've got 14 sevenths, 17 sevenths, 20 sevenths. What's happening? What jumps are they making? What steps? So we can say, right, we can count on 14, 15, 16, 17, 17, 18, 19, 20. It's 3 each time. So from 20 sevenths, we would add 3, it would be 23 sevenths. Then we can add it again to 26 sevenths. And then we add again to 29 sevenths. Okay, so we know that is the sequence at the top. But we've done the improper fractions there. Now we need to come down below. And we need to say, right, okay, we've got 2, and then we've got 2 and 3 sevenths. And again, we can look at that and say, right, how many 7s are in 14? There are 2. Okay, 2 7s, there are 2. Sorry, how many 7s are in 17? There are 2, makes 14, yeah? That's our whole number there. And then we've got from 14 to 17, there's 3. So 2 and 3 sevenths. Okay, now we can go again, right, 2 and 6 sevenths. And we know that's right because of what? How many 7s are in 20? Again, there's 2, but of course it's 14. And then from 14 to 20 is 6. The remainder 6 we change to 6 sevenths. Now it starts to get a little bit harder. And if we're not sure about this number here, we can go, right, okay, how many 7s are in 23? And we know it's 3 because 3 7s are 21. So we can put 3 there. How many are left over? From 21 to 23 is 2, so it's 3 and 2 sevenths. Okay. We've got this answer here, and we've done that one there, so that's done for us. Nice. So now we're just left with this answer at the end. So we go, right, how many 7s are in 29? And we know there are 4. There's 4 7s make 28, which leaves us with just 1. So we put our 4 there, and we've got remainder 1, which we turn into a fraction, which of course is always going to be a 7, because the denominator, as you notice here, doesn't change. It's just the numerator. So it's 4 and 1 seventh. Okay. So next up, okay. Video again. Let's record it again because voice and my microphone a bit far away. Okay. Next one up is continue this sequence. Okay, so we've got 2 and 7/8, 3 and 1/8, 3 and 3/8. What's happening each time on that? It might be easier to see on here. It's moving up in 2/8 each time. Okay, so we've got 3 and 1/8. We know it's going to be 8s each time, so you can just put in, if you want to, in each of these boxes, the denominator. Put the line, put the 8 underneath. That's always going to be the same. Alright, so we've got 3 and 3/8, and we need to add 2 to 8, so we add 2 to that. So we know it's going to still be 3, so it's 3 and 5/8. Then we add again 3 and 7/8. And this is when it gets a bit tricky, because actually when we add 2 this time it's going to be 3 and 9/8, which of course we can't do, because 9/8 gives us a whole. So we say, okay, we take that whole, we add that to the 3 to make that 4, and then we're left with 1/8. Yeah? So that's 4 and 1/8 in that sequence. Again down here, 5 and 6 sevenths, 5 and 3 sevenths, 5. This time we're going backwards, and we're going backwards in 3s each time, 3 sevenths. Okay? So again, you can get your denominator. We know it's going to be sevenths we're working with, so you can put a little 7 in there with the line. Must have a technical name, that line, but I'm not sure what it is. The name of the line there, okay, each time, and then work it out. Okay, so we've got 5. Now we need to say, right, okay, if we've got 5, we know that's like 7 sevenths. Okay, gives us the 1. So we go, right, 5, take away 3/7. It's got to be 4 because we're going back through this number. It can't be 5 still. So we know it's going to be 4, and take away the 3 from 7/7 gives us 4/7. So 4 and 4/7. And we carry on. We go 4, and we take 3 away from the 4, gives us 4 and 1/7. Now we know we've only got 1/7 here, and we've got to take 3 away, so we know this number is going to change. So we go, okay, we take 4, and now it's going to be a 3. Okay, so we've got this 1/7 here, which does make it a little bit tricky, because what we have to do is, because we've got this number here, we have to count back. Okay, so now 4 and 1/7, we take that away, we know that's going to be 3, that's 3 and 5/7. It's quite tricky, that. It's not simple at all. It's one of those things that actually you just need to know the pattern of the numbers, and that as soon as you've gone through a whole number, then your fraction is going to be a little different too. So, C, next one, you've got 5 and 6/11, 5 and 3/11, 5. This time we're going backwards in 3s. 3/11, okay? So it's 3/11 are going backwards every time. So again, you can do the old trick. Take the denominator, write that down there, put a little line above, so you know that's going to be the same. The fraction is always going to be the same because it doesn't change all the way through. So we know we've got 5, okay, and we're going back 3, okay? So 5, but we take 3 away from the 11 there, because we know it can't be 5 anymore, it has to be 4 because we're going backwards. So we take 3 from the 11, and it's 4 and 8/11. Now we take 3 from this 8, okay, and that gives us 5. So 4 and 5/11. And then we take 3 from this, we're still okay, we're not going to have to go through any numbers and make it a 3. So we take 3 from the 5, gives us 2/11, so 4 and 2/11. And then there's a little question here that says, what is the same, what is different about the sequences in part B and part C? And what's the same is, actually, they both start off with 5 as the whole number. They also both start off with 6/7 and 3/7, so they're going back in the same number, but, of course, what's different is the denominator is different. Okay, so whereas this one here, it crosses over into the 3s, this one here doesn't, because the jumps, or the number of jumps needed to go through 11/11 is a lot bigger, it's a lot higher. Okay, so that one isn't going to go through until the next one, where it'll be 3 and 10/11. Okay, so that's that one. So it starts off almost the same, but because we're working with a smaller fraction, smaller parts broken up, it takes more before it gets through to the next number. Alright, next one. Match each sequence to its rule. So we look at this and we say, right, 2 and 2/3, 3 and 1/3, 4, 4 and 2/3, sorry. Okay, so each time you need to look at this and say, okay, actually if we look at this, the jump between there and there, it's quite hard for us to understand. You might be able to do it from there. Actually, it's easier to look at these two numbers here and say, right, what is the jump from 4 to 4 and 2/3? And of course they've added 2/3, so draw a line, there we go, to add 2/3. Next one is 2 1/2, 3 1/4, 4, 4 3/4. And again, if you look at these two here, it might be a bit confusing. You might think, do you know what, that is tricky. I'm not quite sure what the fraction is, what the jump in the fraction is there. But if we look at this here, from 4 to 4 3/4, we can see that they've added 3/4 to the 4. So that must be right. Add 3/4. Next one is 4 and 1/3, 3 and 2/3, 3, 2 and 1/3. Okay, so now this one is a little trickier. Yeah, this one's a little trickier because actually what we're looking at here is the jump between there and there is quite confusing. The jump between there and there is quite confusing, but actually, the jump between those two numbers, or the sequence between those two numbers, isn't so tricky. So if we look at that, 3 and 2/3, 3, we are going back 3, we are subtracting 2/3, because that's 3 and 2/3, and that's 3. So we can then go, and then that should leave us with this one here. Okay, so we've got 4 1/4, 3 3/4, 3 1/4, 2 3/4, and that leaves us with subtract 1/2. That's our last one there. Okay. Right, so there's Teddy and Rosie are finding the mixed number in the sequence. I think the missing fraction is a 7th because there are 7 blank cards. Do you agree with Teddy? And the answer is no. Okay, because actually, if it was 7th, it would mean that there would only be 6 blank cards, because 3 and 7/7 equals 4. Alright, so there would only be 6. So we don't agree with Teddy. Right, complete this sequence. So 3, so what we have to do is go 1, 2, 3, 4, 5, 6, 7. So if we look at this, okay, this is, we know that because of what Teddy has said, that it's not 7ths between there. We know it has to be 8. So if we go 3, 3 and 1/8, 3 and 2/8, 3 and 3/8, 3 and 4/8, 3 and 5/8, 3 and 6/8, 3 and 7/8, whole, 3 and 8/8, or 4. And she says, I think one of the missing fractions is an equivalent to 3.5. So this is what Rosie says. So if we look at it, we know that half, when we're looking at fractions, is if the numerator is half of the denominator. And we can see on this one here that 3 and 4/8, the 4, the numerator, is half of the 8. So the answer is, good old Rosie is correct. So 4/8 is equivalent to half. So 3 and 4/8 is equivalent to 3.5. And it says, which other fractions in the sequence can you find equivalent fractions for? And you could look at that and you could say, okay, so 3 and 6/8, we know that could be 3 and 3/4. That would be an equivalent fraction. And if we went down to there, 3 and 2/8, we could say, okay, we know that there are 4 2s and 8, so that could be 3 1/4. So that's another equivalent fraction. Okay, so 3 and 2/8 is the same as 3 and 1/4. It says, lastly, Anir, I am thinking of a number sequence. The first and fourth terms are consecutive integers. What's the rules for Amir's sequence? Okay, so basically what you could do is you could write any numbers, any two numbers, okay? Any two numbers, and you'd go, right, okay, you could have 1, and then you'd have a gap, 1, 2, and then lastly you'd put in the fourth. So you don't need, basically you need 4 marks, 1, 2, 3, 4, and you'd have 1 there, and you'd have 4 there, and you'd say, right, what's the jump between each one? And actually you'd know 1 and 1/3, 1 and 2/3, and the last one will be 1 and 3/3, but of course we don't say that, we would say 2. Alright, so it's adding 1/3. Alright, that's what's happening there with Amir. So Amir is doing that. I hope that helped. I hope you've managed to get through and get some of those correct. Challenge, it's quite challenging, that one today. It's taken me quite a long time to get through just explaining it. It seems to be happening at the moment. The input video doesn't seem to be as long as the actual results answer video, but have a go. And if you do that, or if you want to have a go at some of the extension stuff, the extra work, then please do. Thank you very much again.